Salam sejahtera. My name is Wilma Marius.
My name is Nur Akila Amani binti Muhammad Asman.
My name is Nur Izzati Shamimi binti Muhammad Yusuf.
My name is Nur Aina Suhan binti Nur Suhaimi.
Today, our group will be presenting an analysis of the COVID-19 cases in Malaysia. The dataset presents the monthly number of COVID-19 cases in Malaysia from January 2021 until October 2021. This data is obtained from Ministry of Health MOH Malaysia through its official reporting platform. The report is based on the assumption that the case number recorded in the first day of the following month represent the total case for the preceding month. It also provides information on the spread of COVID-19 throughout the country. The reported cases represent the individuals who tested positive through the official testing and reporting system. The dataset was selected since it provides meaningful information about the impact of COVID-19 on society that is related to our daily life.
First and foremost, we need to use command with linear algebra and with plots to unlock all the features in the maple before plotting the graph. Then we need to substitute all the data in the table. To model the trend of confirmed cases by using the linear equation, we must use y equals to a plus bs, where y represents the number of confirmed cases, x represents the months, a is the y-intercept while b is the slope of the graph. Next, we need to convert the data into the matrix form, which is AS equals to B. For matrix A, the first column consists of the coefficient 1, while the second column is the month values. Matrix B contains the number of the confirmed cases for each month. To determine whether the system has an exact solution, we form the augmented matrix M equals to A augmented with B. Then we need to apply reduced row echelon form RREF method of matrix M. After applying this method, the system is found to be inconsistent. Therefore, an exact solution does not exist. Since the solution is inconsistent, we need to apply least square method. First, we need to transpose matrix A. Then multiply the transpose matrix to matrix A. After obtaining matrix A transpose A, we compute matrix A transpose B. We need to find the determinant of matrix A transpose A. Since it is not equal to 0, hence the normal system has unique solution. We form augmented matrix N equals to A transpose A augmented with A transpose B. Therefore, we apply reduced row echelon form RREF method. This is to find the numerical values for the slope and y-intercept of the best fit line. From the solution, we get the value A is 768,064 over 15 and value B is equals to 5717341 over 165. Substitute the value of A and B into the linear equation. Then, plot data command is used to plot the given data point. Use command plot linear and insert the linear equation to display the straight line. We need to use command display plot data and plot linear to get the linear graph obtained from the confirmed cases of COVID-19. To get error vector for linear graph, we need to insert value of A and B into matrix S by using the formula of error vector B minus AS, where B represents the actual value and AS is the predicted value. After we get the error vector, we need to find the magnitude of error. Since the data that we obtain is in the fraction form, then we need to change it into the decimal points by using the above command for the easier interpretation. Hence, the magnitude of the linear equation is 496,406.1996.
I will show the quadratic and cubic graph as well as the magnitude of error vector that we obtain. For quadratic, here is the data plot. The graph on the left shows the quadratic curve while the graph on the right displays the combination of both previous graphs. This is the magnitude of error vector for quadratic. For cubic, the graph on the left is the data plot and the graph on the right is the cubic curve. Here is the combination of both previous graphs. And here is the magnitude of error vector for cubic. For this section, we compare the linear, quadratic and cubic curve to determine the best fit curve. Based on the table, the quadratic curve produced the minimum error compared to the linear and cubic curve. Therefore, the quadratic curve was selected as the best fit curve. The quadratic equation was then used to predict 3 data points that were not included in the original dataset. So, after choosing the quadratic curve as the best fit curve, we use the quadratic equation to predict additional data points. Then, we substitute different values of P into the equation to obtain the predicted values for the middle of the May 2021, November 2021, and December 2021.
This slide shows our prediction and conclusion for the 2021 Malaysia COVID-19 data. In mid-May, it predicted 338,445, which matched the actual rising trend. In November, the predicted cases are aligned with downward trend from July until October. Then, toward the end of the year, it showed a clear downward trend where the predicted cases was dropped to 68,644 cases by December, proving that outbreak was dying down. In conclusion, the quadratic curve is the best fit because it produces the lowest error compared to the linear and cubic curve. For future studies, we recommend using a large dataset with more use of data, and we should avoid predicting too far beyond available data to keep results accurately. That's all from us. Thank you.